Now this is everybody is another good simulation regarding DC motor. Do check, it's really good actually. I have shown you DC motor and various parts of the DC motor during the lecture. I'm going to record this simulator once again so that you will have more detailed information. Now we can look at it from different angle. As you can see, there is a concave shaped magnet, armature coil, contact brush, and there is a split ring commutator. Now let's play this simulation. Let me introduce the magnetic field. Now basically the magnetic field inside the the DC motor is radial magnetic field, because we use concave shaped permanent magnets. They are not flat actually. They are concave shaped and they provide radial magnetic field. Now what is radial magnetic field? It's another topic. We will discuss radial magnetic field in another simulation. Let's focus on the working of this DC motor. Now let me switch on the current, torque, and let's run the DC motor. And as you can see, it's really rotating quite nicely. It's just a simulation, yeah. So basically it works on the principle that a current carrying conductor experience force in the presence of transverse magnetic field, and this is the principle of motor. So there is a current carrying wire, the current carrying coil in the presence of magnetic field, and the force is acting on both the arms, producing the moment of force, or we also call it torque or moment of couple. Moment of couple in this case, the common name is torque. So torque is acting on that coil and hence it's rotating. So what is the principle? Current carrying conductor experience force in transverse magnetic field. That is the principle of motor. So motor converts electrical energy into mechanical energy. Now let's talk about various parts of this motor. So there is a split ring commutator. Let me pause it for a while and let's see how does it look. Let me pause it right there. Oops, I just missed it. Let me pause it again. Oh yeah, thank you very much. Now let me look at it from different angle, and you will see there is a gap actually. There is a gap. So that's why we call it split ring commutator. And when this gap, because of this gap, the current will reverse the direction through both the arms of the coil. So the torque will always act in the same direction. So let me just rotate it. Yeah, let me just play it and wait a second. Okay. Oh dear Lord, yeah, I just missed it. I just wanted to say that when this gaps comes in between, the current will not flow through the circuit. Yeah, right there. Oh, I just missed it again. No problem, let me just stop it here. Yeah, right there. There is no contact now and current will not flow through the wire. Let me show it from the different angle. As you can see, there is no current flowing actually. But due to the inertia of motion, it will still continue rotating. Now, see, the current is flowing now. So when that gaps come in between, current will stop flowing. Right there, as you can see. So split ring commutator, it reverses the direction of current, as you can see. So through both the arms, torque will be constant. Permanent magnet is there to produce radial magnetic field. We can also increase the number of turns of the coil. If we can increase the number of turns of the coil, the torque will be maximum and it will rotate faster. So there are basically three factors on which the rotation speed of the coil depends: number of turns of the coil, the magnitude of the current. More current if you supply, it will rotate faster. Third one is iron core. There is no core they have shown here, but if we can introduce the iron core, it will increase the torque and it will rotate much faster. The fourth factor is strength of the magnetic field. Stronger the magnetic field, more stronger will be the torque and it will rotate faster. So how many factors are there? Number of turns of the coil, magnitude of the current, iron core, and radial magnetic field, the strength of magnetic field. On these factors, the rotation speed of the DC motor depends. So electromagnetism based topic, it converts electrical energy into mechanical energy. And what is the principle? The current carrying conductor experience force in the transverse magnetic field. It's a very important device. I have shown you the internal parts of the motor, and I have made a few motors during the lecture. I have shown you a few motors, working of the few motors. This simulation is really good. Do check it.